band and the lower KU band. And what the beauty, I think, of this is also that this is enabled because it is basically the reuse of existing COTS. Let's say existing 2.4 gigahertz amplifiers, the modification of low noise blocks that you use for normal television for, let's say, maybe 10 and even less euro, and you modify them, and then you can use this satellite. So with relatively low cost, you can communicate with its satellite. And this satellite payload, and there is a lot of, actually, in particular, German amateur radio and also UK amateur enthusiasts who have been instrumental in getting, let's say, a community working over this payload on the SHIL-SAT-2, which is the name of the commercial satellite. This was the first time that, say, radio amateur satellites were also able to have, let's say, more continuous communication between each other. And you can see here the footprint. Let's take the green and the red line there. That is linked to what kind of elevation you need for the antenna. But this goes from Brazil to Indonesia. So you can have, say, in a single hop, basically, a user from Brazil could communicate with a user in Indonesia. So there's an enormous potential there for all kinds of experiments. And this has also led to more broadcasting using standards like DVB-S2, which is very active at the moment in QO100, where, let's say, new technologies went into the amateur domain, and the amateur domain is now making very nice open source implementations of mini tuner and all various DVB-S2 equipment. That is something we would like to support. But how do we support that? Now, a longer time ago, these processes do not go that fast, unfortunately. We wrote a letter to IARU, the International Amateur Radio Union, from where I think Sylvain is one of the bosses, I would say, divided in various regions of the world. We wrote there, or we, let's say, stimulated the letter, and IARU basically asked ESA, could you not help? We need to think at least maybe of a follow-up of QO100. We asked that, as you probably know, we are publicly funded, so the various countries want to have their say. Everybody did their say and say, that's okay. We hear you have some funding. So we have funding to start that process, and that funding is meant to collect requirements and also make a few prototypes maybe. Basically, it will not be enough basically to host a satellite or a payload on a satellite. That will be not possible. We have to look for other funding mechanisms for that later, but we'll come to that later. So what we will be doing is to identify requirements of all the people in Europe and Canada. Canada is one of our member states, to identify what would be good requirements to fulfill for a next geostationary payload. And back to the orbit, geostationary or other orbits, we have been heard that some people would be quite interested also to explore maybe payload in medium Earth orbit. You can imagine that also then you have a longer contact time, and it still has a bit like a global attractiveness. We are considering that because there might be various institutional initiatives starting soon where there could be hosting opportunities for small payloads on medium Earth orbit. Now, so we will be looking at various further in the amateur community. That process will start very soon. We already requested a few inputs, and we still have to process all that. And we will then talk to the various satellite operators to see how we could accommodate then a payload and how to get the funding for that. So the first ideas we heard already, that is a few people would be very interested in, let's say, keep it simple. Actually, the payload which is currently on SHIL-SAT, it is fantastic that it's there, but functionally you could say it's rather simple. It's an analog transponder. What you go up in whatever modulation you use, that comes down. And many people like that also, because that means a lot of experiments maybe at the modulation level, more the deep down RF level. There is also a whole community that comes more from that have been raised with SDRs, let's say, starting more at that level. There's a whole community that is more working at the, let's say, the IP level and even higher in the amateur world. And we have to find a bit the balance from these maybe simple payload designs to maybe something which is really more complicated. And You can imagine also in the amateur world, there are communities that are going up and up and up in the frequency range. And in the amateur community, we have 24 gigahertz, we have up to 77 gigahertz, which we all could use for satellite. But you could imagine that going higher up in frequency also means that possibly you have narrower beams. And for the other hand, you would also like maybe that the satellite community is served by, let's say, more in a larger scale. If we have one very nice spot beam in E-band, let's say in 76, 77 gigahertz, yeah, that will serve probably one country. That is not so, let's say, inclusive, I would say. So there's a few balances there to be made. But it would be quite nice in some way to come to a combination that already some people have suggested, where we have an analog transponder. And actually what you would like maybe is to have in geo orbit basically the ultimate Linux brick with everything around it. And then everybody can do what he wants. The only, also here, the disadvantage is again that if we put something like this on board, then we get a certain degree of centralizing things. You need a sysadmin for this satellite, basically. And that is not always to the liking also of the amateur community. One likes sometimes a certain degree of chaos, let's say, and anarchism and so on, that it should not be too regulated. So also that is a bit of a balance to be made. But we have heard various ideas to put it also a bit more in the 5G area, where maybe CU, DU, certain splits in the whole 5G architectures could be partly put on board. Because many people, even in the amateur world, start to look also at various communications based on 5G, non-NTN, non-terrestrial network. So various trade-offs to be made. We listed here a few of those, and we will now start a larger consultation on all those topics. Back again to, let's pick a few, let's say the attractiveness of future user terminals. Like the example here previously of the ground-based SAR, 6,000 euros, in this case the opportunity of some taxpayers' money. What is acceptable later on for a radio amateur? If we go to the 77 gigahertz, maybe we can use automotive radar hacks and so on. That needs all to come together. So we would like to request later on, in a more structured way, input from the amateur community, but also taking into account all these factors, because it's no sense proposing something where not a lot of amateurs can benefit from. So that we are currently starting, and we'll show you a little bit what we will be doing in the next month. I will not go into detail of the planning, but what we now are going to do, we are talking already a very small group to get a bit of a sense whether what we should do, and also in particular what ESA should not do, because some things are far better left to the amateur community. We prepare a bit like a consultation, we talk to the amateur community, and we also talk to a number of, let's say, people who would likely build such a payload. It is, however fun that would be, it is not so likely that the amateur community would build such a payload themselves. A geostationary operator with a 300 million satellite would like to know what he hosts as the few kilos extra. And that is not so likely that he will accept that that is built by amateurs, how good they are also. With all respect, he will not accept it, and his insurance company will not accept it. And what we would organize in May is a day in ESTEC, also with support from our technical people, to discuss a few options. Start prototyping. We have the funding for that, to prototype a bit what some people call like a flat SAT. So it's the model of the satellite, but you basically put it on a table. And we would like actually to have a few ideas ready in September. September, there is always a very large satellite conference where all these satellite operators are, and we are making there the appointments. And we will also pitch this to satellite operators as a bit like let's say, as a good thing. Many people complain in the satellite world about the lack of people that understand RF. That is a real lack. a lot of people, there's a lot of programmatics, but there's not so many people that can understand RF. And also, I think satellite operators have responsibility to, and also the industry, maybe to stimulate that the young people start to understand satellite communications. That is at least also one of our objectives, to get more people enthusiastic about satellite communications. Good, that's what we'll be doing in the next year, you could say. So we hope in May, we'll advertise that lately, May or June, we'll see a little bit on availability, to organize a day to go through a number of payload designs. And we're also trying to get, let's say, some travel reimbursements and so on in place, so that people could come to us. And hopefully in September we discuss a few things with satellite operators. And even better, we hope that maybe the outcome of such a discussion could be discussed at a next FOSDEM, hopefully next year. I think that's it from our side. You'll hear more from us. And as said, it's not such a technical talk, it's a process we're starting, but all your technical inputs from the AMSATs, the amateur satellite organizations in the various countries, which we are approaching already, but also individually, would be highly appreciated. That's it. Thank you very much.
Thank you, Frank. I give one or two questions.
Please. Yeah.
Yes, is there any option for phased array or beam steering, or is it way too expensive for such things?
Yeah, that would be, it would be indeed very nice, of course, if we look at the, let's take first phased array on board. Yeah, of course, that will then be highly dependent on the frequency range. Let us assume it would be an E-band, 77 gigahertz amateur phased array. Yeah, that would be a fairly expensive thing, but I think we are also there to see whether maybe certain developments could spin off further in industrial developments. So this would be a good. I only see, of course, again, but also a phased array. It needs a type of management of that beam that comes with that. And of course, it's still a challenging development, of course. On the ground, maybe if we take now the scenario of a medium Earth orbit where you would need pointing, then I can see there that also from the amateur community, the various YouTube videos that appear with the educational Pluto beam steering and things like that, there I see a lot of opportunities to do beam forming, to educate people on the essentials of beam forming, with maybe an existing beacon that comes from the MEO. I think that would be excellent to do that. Yeah. Oh, please.
Do you intend supporting, say, Canada into this? Yes, so there's a bit more interest.
Sorry, support what?
Support Canada and obviously there's some elements in.
Yeah, okay, the question was about the geographical thing. Canada is also part